Unit 2, Density. Please recall that there are two different properties of matter, chemical properties and physical properties. Physical properties include things like mass, volume, length, weight, color, anything that we can observe without changing the chemical makeup of the substance. Chemical properties must change the substance's composition, so things like flammability, the ability to burn in the presence of oxygen, and reactivity are also chemical properties. Since density is the relationship between an object's mass and volume, where should we put density? Density is a physical property. There are two major ways to determine volume. The volume of an object can be found by using an equation. If the object is a cube or something rectangular, we would use length times width times height. But what if the object is irregularly shaped? We would then use the volume displacement method or Archimedes' principle. Let's practice using an equation. If we were to determine the volume of an object that is 4 centimeters long, 3 centimeters wide, and 2 centimeters high, we could use the equation volume equals length times width times height. So subbing in our values, volume equals 2.0 times 3.0 times 4.0. And we would see that volume is equal to 24 cubic centimeters. How do we get that cubic centimeters? Well, we take centimeters times centimeters times centimeters. Since we multiplied centimeters together 3 times, we get centimeters cubed. The water displacement method, we would start with a given amount of water in a graduated cylinder. In this case, it's 1.5 milliliters. We can then add an irregularly shaped object to the cylinder. The new volume, 1.9 milliliters, is a result of the volume of the water plus the volume of the object. So the final volume minus the initial volume equals the volume of the object. So 1.9 milliliters minus 1.5 milliliters equals 0.4 milliliters. Let's look at another example. If we want to measure the volume of a toy dinosaur, we can't measure the length and the width and the height, so we'd need to use Archimedes' principle. We take an initial reading of the volume of water, and we see it to be about 4.80 milliliters. We place the dinosaur into the water, and the water level rises to 5.60 milliliters. So to determine the volume of the dinosaur, we need to take the volume of the water and the dinosaur and subtract the initial volume of the water. So we take 5.60 minus 4.80, giving us the volume of the dinosaur, 0.80 milliliters. Since density is a ratio comparing an object's mass to its volume, we need to be able to use and work with our ratios. Let's look first at the units for density. Okay? Pay attention to these. The units are grams per milliliter or grams per cubic centimeter. Remember that when we divide something on a calculator, we press the divide button. That looks like this. So in both of these, we have little division symbols. So this can help us figure out our equation. The equation for density is mass over volume. So suppose we have a sample of aluminum that has a mass of 13.5 grams and a volume of 5.0 cubic centimeters. What's its density? Well, density equals mass over volume. The mass is 13.5 grams, and the volume is 5.0 cubic centimeters. We plug these into our equation, and we see density equals 13.5 grams divided by 5.0 cubic centimeters. Rounded to two significant figures, the density of this object is 2.7 grams per cubic centimeter. What's the volume of a sample that has a mass of 20 grams and a density of 4 grams per milliliter? Using the same equation, density equals mass over volume. The mass of the object is 20 grams, and the density of the object is 4 grams per milliliter. Plugging these into our equation, we have 4 equals 20 over x. Whenever we have an unknown in the denominator, what we first need to do is multiply both sides by our unknown. So on the right side, we have x in the numerator now and x in the denominator. So they cancel out. This leaves us with 4x equals 20. We divide each side by 4, giving us x equals 5 milliliters. Why does ice float in water? Well, liquid water has molecules that are tightly packed together. And when that water begins to freeze, those molecules begin to spread out. This means that the same water molecules take up a greater amount of space. This increased volume leads to a different density. The density of water is 1.00 grams per milliliter. You should probably know that. And the density of ice, because of the greater volume, the density of ice is 0.92 grams per mil. So, if we assume we have 100 grams of water and 100 grams of ice, how much space, what is that space difference that we're talking about? Well, the volume of 100 grams of water, the density of water is 1.00, 100 grams of water, so we're solving for V. Just like we've done before, we'll multiply V by both sides and get V to cancel out, leaving us with 1.00 V equals 100. So we divide each side by 1.00, and we see that V equals 100 milliliters. If we look at ice, the density of ice was 0.92 grams per milliliter. So it's 0.92 equals 100 over V. Just like before, we will multiply each side by V, getting V to cancel out on the right side. And this would leave us with 0.92 V equals 100. So we divide by 0.92, and we get V equals 109 milliliters. So we see a 9 milliliter difference between ice and water. So as long as the density of ice is less than the density of water, ice will float. It doesn't matter what size ice we're talking about. Even something like an iceberg. Something this big still floats on water because the volume to mass ratio for the ice is smaller than the mass to volume ratio in water. One of the ways that we can see this is by looking at what we call a rainbow column. Rainbow columns use things with different densities. If we look the objects with the lower density, things like lamp oil and rubbing alcohol, are at the top, while things with the higher density, things like the Karo syrup and honey, are at the bottom.